Hello, this is Varun Bhaskaran, and in today's lesson we'll be going over conversions and dimensional analysis. Now, to begin with, there are always prefixes. In chemistry, there are many numbers that are big and small. Prefixes are used to represent these numbers in chemistry. The smallest number has the prefix pico, which is equivalent to 10 to the power of -9. The largest number has the prefix giga, which is equivalent to 10 to the power of 9. Now the difference is of the signs. You can see that there's the positive and that there's the negative. In between deci and centi, there's the base unit. Now it's not in this chart, but it's good to remember. Now, what is dimensional analysis? It's a tool that we use in chemistry and it's very essential in problem solving, and it's an organized way in converting. Now we have a few examples here. So number one, we have 100 milliliters to liters. So we're going to use a reference chart on the right here, and we're going to start off we're going to use what's given to us. So we're given 100 milliliters, and what do we want? We want liters. So we're going to write 100 milliliters, and to cancel out the milliliters, what we're going to do is we're going to put milliliters on the bottom, and then we're going to put liters on top because that's what we want as the outcome. Liters is what we want in the end result. So for every 1 liter, there's going to be 1,000 milliliters. So according to the chart on the right, as you can see, it says that in 1 milliliter, there's 10 to the -3. So what we're going to do is do that, and we're going to end up with 0.1 liters in 100 milliliters. Number two, 10 picograms to kilograms. So always remember to start with what you're given, 10 picograms. So we write down 10 picograms, and we're going to convert it first into grams. So we're going to put picograms on the bottom, grams on top. For every gram, there are 10 to the 12th power of picograms, as you can see on the chart to the right. If we go here, 10 to the -12. Then we're going to convert to 1 kilogram, because we don't want grams, we want kilograms. So we're going to go from grams to kilograms. So grams are on top, so we put grams on the bottom, and then kilograms, which is our end result. So in every kilogram, there are 1,000 grams. So as you can see, it's step by step. What we're doing is we're canceling out the picograms here, and then we're canceling out the grams to eventually give us the final result that we desire, which will be kilograms. Now, let's go on to more of a word problem. So we have 5 microliters. So that's the symbol for microliters. So we're gonna start off with what we're given. We're gonna go from microliters to liters. Then what we're gonna do is we're gonna go from liters to deciliters. And eventually, using the conversions given on the right, we're gonna get 2 times 10 to the -4th deciliters. Now, how are we gonna use these concepts in real life? So let's say a weightlifter can lift 495 pounds. So in America we might use pounds, but in other parts of the world they might use kilograms. So a universal conversion factor is going to be for each pound, it's going to equal 2.2 kilograms. So we're going to use that. So we're given 495 pounds. So we're going to start off with that. And we're going to multiply by 1 kilogram over 2.2 pounds. So what that does is it's going to cancel out the pounds, and we're going to get our final result in kilograms. Now, things to note. You will need to memorize units of conversion for chemistry, as a lot of chemistry classes expect you to memorize units to solve these problems. Now, this is just the introduction. There are more complex things in chemistry which you will need to know dimensional analysis for. Now, this is just a beginning, so you can be more comfortable, and a good way to do that will be through practice problems. Thank you.